Good morning to all. I am Dr. Janardhana Rao, Associate Professor, Institute of Aeronautical Engineering College. We are discussing about operating systems, some certain concepts, and we have discussed about file systems, how the file is created, how the file is deleted, how the file is saved in the system. And today we are discussing file system mounting. So the file system is the part of the operating system which is responsible for file management. It provides a mechanism to store the data and access the files it contains, including data and programs. Some operating systems treats everything as a file, for example, Ubuntu. So actually, whatever you want in the save in the system, that will be considered as a file, or let it be a program or a document that is considered as a file only, and it is saved in the hard disk. Once it is saved in the hard disk physically, C drive, D drive, and E drive. So some it is saved here. Once it is saved here, so next to this D drive, we will have the directory of this D drive. In the sense, in this, what are the files saved in this D drive? About these files, we will maintain one record in the just below the D drive, the hard disk itself. Some place is allotted, that is directory for the D drive. We will see in the coming classes how this is saved in the hard disk. That what file mounting. The file system takes care of the following issues. As we have seen, there are number of programs in the OS, and some programs, as I told, OS is a package. This is OS, and there are a number of .exe files are there. Some programs will work for the process management, some programs work for the process security, some programs work for the file management. Some like this, different programs will work for the different operation. That is just what application of your OS. So today we already seen some of the programs which are responsible for the file management, file system, how to save the file in the hard disk, and how to maintain the directory, and what is indexing, and all the things we'll see. So once file is created, so about that file, we should keep some information in the directory. So the file structure. The files can be stored in various data structures. The task of the file system is to maintain an optimal file structure. So recovering the free space. Whenever a file gets deleted from the hard disk, there is this. So as we have seen, this is your hard disk. So as we seen, C drive, D drive, E drive, and we have saved one file here, and regarding this file, we maintain one directory in that hard disk itself, just below the D drive. So once this file is created, and as we have seen the application of this file, and if you delete this file in the hard disk, so whatever the information about this file saved in the directory also, everything will be deleted from this one. So that is then once we deleted this one, then we will get the free space in that D drive. So that is nothing but free space. Whenever the file is get deleted from the hard disk, that space is free. So some other file can be saved there if the space is permitted for that file. So whenever a file gets deleted from the hard disk, there is a free space. There is a space created in the disk. So there can be many such spaces which need to be recovered in order to relocate them to other files. So that is nothing but, so like this situation, there may be some other situations. If some files deleted in the different drives, then the free space will be created. So the file system mounting. Operating system organizes files on a disk using the file system, and these file systems differ with operating system. Create number of file systems available for Linux. One of the great benefits of Linux is that we can access data on many different file systems, even if these file systems are from the different operating systems. In order to access the file system in the Linux, first we need to mount it. So mount in the sense placing the file in a proper order under which directory. So it is done by attaching root directory from one file system to the other. So this ensures that the other directory or device appears as a directory or subdirectory of the system. So just you see the diagram. See, this is nothing but root. From here, this is another user. Under this one, we are mounting the file like this. So file systems may be mounted read-only or have other restrictions imposed. So this where we are placing the file in the directory. That is nothing but a file mounting. The file system mounting, the traditional Windows OS runs an extended two-tier directory structure where the first tier of the structure separates volumes by drive letters and tree structure is implemented below that level. Macedonis runs in a similar system where each new volume that is found is automatically mounted and added to the desktop when it is found. More recent Windows systems allow file system to be mounted to any directory in the file system, much like Unix. So where we are placing the file and which directory we are placing file, that is nothing but file mounting. Once file is saved in the hard disk, then regarding that file, we should have a track where it is under which user or which where it is saved. The indexing or easy accessing the file from the indexing to the physically where the file is saved. That is your file mounting. So file sharing. The file sharing is the public or private sharing of computer data or space in the network with various levels of access privilege. So whenever we share a file to anyone in the internet, then we should have some permissions. So it can be open or it can be read or it can be only read only. It can be executed also if it is a program, and you can do modifications and you can execute the receiving person. So that while files can be easily be shared outside a network, for example, simply by handling or mailing someone your file and it is diskette. The term file sharing almost always means sharing files in a network, even if in a small local area network. File sharing allows a number of people to use the same file or file by some combination of being able to read or view it. So write or modify it. So that is file sharing. So I am the other. I have created one program. If I share that file to others through internet, so when the other person receives it and he download it, and you can see that, you can read it, you can write, you can do modifications. So that is the thing. That's called file sharing. File sharing allows a number of people to use the same file or file by some combination of being able to read or view it, write or modify it, copy it or print it. Typically, a file sharing system has one or more administrators. So users may all have the same or may have different levels of privileges. That's what our insistence is. Once the file is shared to some of your friends or some of the people, so once they look at this file, so what extents they can do modifications and any there's authorization to the file. Once it is shared, so only they can read it. So that authorization that we are providing security to that file. So you cannot claim their originality, copyrights. The file sharing. File sharing, also known as file swapping, is the accessing or sharing of files by one or more users. It is performed on computer networks as a quick way of transmitting data. Generally, a file sharing system usually has more than one administrator, where the users may have the same or different access privileges. Once the file is downloaded, so access privileges means only read-only file, or there is a possibility of more rights for modification and execution, and that's what the privileges means. It is also implies having an allocated amount of personal files in the common storage. File sharing has been used in mainframe and multi-user computer systems for many years, and now with widespread access to the internet, a file transfer system known as the File Transfer Protocol or FTP is widely used. So the World Wide Web in itself can be considered as a large-scale file sharing system where files are constantly downloaded or viewed by the web user. In the file sharing system, the user can read and write in the files. And if the entire system is not available for access, at least the common file that is shared by the owner can be read and write too. Certain issues arise when multiple users are allowed to access the files. So the system can either grant access to the users by default or requires the users to specifically grant access to the files. That's what. Once I uploaded one file, so I should grant the access to the other people whom I sent. So I should give the grant access. Otherwise, he can share, he can download, but he cannot open. That's what privilege is. This causes problem of control and protection. And to implement sharing and protection, the system needs to maintain more file and directory attributes than it would have done in the case of single user system. So as I told, it is providing the security privilege to the file sharing. Even the file is shared, but the receiver cannot open that file. The sender should give the access to the grant access to the users by default. Requires the user to specifically grant access to the files. Otherwise, you cannot open. This is the file sharing security. The protection. The protection refers to the mechanism which control these access of programs, processes, or users to resources defined by the system. So this is a protection. We are providing the protection to the files. So even the file is shared, the authorized person only can open that one. Simply once you are sending the file or sharing the file through internet, the other person who has received it, you cannot simply open because the access grant should be given. Many users might safely share a common logical names space such as directory or files. Users want to protect the information stored in the file system from improper access and physical damage to the originality. To protect our information, one can make duplicate copies of the files. Some systems automatically copy the files to protect the users from the losing important information if the original files are accidentally destroyed. So we keep the duplicate copy. So there can be situations of hardware errors like extreme temperature, vandalism, the damage, head crash, failures, etc. They may cause damage to the files. So to understand protection better, need to understand the types of access the file. So in types of access, file sharing. That's once we share the file, other user can open the file and if access is granted. So file sharing is the method of providing partial or fully access to the users of the system file system. As multiple users have access to the same data, if there is need for protection. One way to protect the file system can be prohibit access, but it is an extreme scenario and it is not practical use. So what is needed is controlled access. It may depend on various factors. So these are the following operations that can be controlled. So delete operation, append operation, execute operation, read operation, write operation, and listing. So protection is provided only at lower level. For example, copying file may be implemented by simply providing a sequence of read requests. In this scenario, user with read access can copy the file and print it and so on. So access controls. There are numerous ways of access any file. One of the permanent one is to associate identity dependent access with all files and directories. A list is created called access control list, which enlists the names of users and the types of access granted to them. However, it is very long as the users need to be listed down. The processes can often be tedious and unrewarding, especially if one doesn't have the list of users before the task. To resolve this situation and condense the length of the access control list, the following classifications are used: ownership, group, and universe. The user who created the file is a owner. The set of users sharing the same file, the group of the people. So all are permitted to access that file. That is universe. All the users. So protection. Other way of protection, another approach is to password to enable access to the file system. So whenever the file is created, we provide the protection to that file. Other cannot open that file. That by providing the password to the file, we don't give access to the other people. Other people, without knowing the password, they cannot open the file. That's called the password system. In the password system, only the other can open the file. That is password. However, this method has certain disadvantages. If one password is used for all the files, then any situation where the password happens to be known by the other users, all the files will be accessible. It can be difficult to remember a lengthy and large number of passwords. So these are the disadvantages, and we see the protection, the file system protection. So the file system provides efficient access to the disk by allowing data to be stored, located, and retrieved in a convenient way. That is the initial step. A file system must be able to store the file, locate the file, and retrieve the file. So as we know, since beginning, how the file is created, how the file is, where is the file is stored physically, and how to retrieve the data from the physical memory, and it all comes under the file system must be able to store. The file system is a system number of programs in the OS. These programs must be able to store the data, locate the data when the user wants see that. So locate the data, file, and retrieve the file. So this is a common work, or whenever the file is created, means file is saved in the hard disk. So most of the operating systems use layering approach for every task, including file systems. So this is as you see, there are number of programs in the OS for file processing, and these programs are layered, one to one layered. So every layer of the file system is responsible for some activity. So some programs will do some operation for creation. Some programs are retrieving the data. Some programs are providing security, and this is layered. These programs are layered. So this is application programs. That is nothing but programs in the OS. So these programs, logically file system, it is a logical system because all these programs, OS programs are interlinked for the file system. So file organization module. So in this one, some programs will work out for the file organization module, and basic file systems, IO control devices, and what that is devices means saving, writing, and reading. These are the ultimate devices, means which are the programs are interacting with the hardware. These are the programs. This is your OS, and these are the programs are laid onto one because these programs working for the file in the OS. Some program will work for the process like this security. So these programs are for file system management. These programs are interlinked like this. Ultimately, read and write system calls will interface with the devices in the hard disk. So this is how the layered structure of your files. So in this concept we are discussing file system structure. What is the structure of file system? When an application program asks for a file, the first request is directed to the logical file system. Logical file system. It is the application program. If the application program doesn't have the required permissions of the file, then the layer will throw the error. Logical file systems also verify the path to the file. So as we have seen, the programs which are related to the file system management, these programs are layered one to one. They are interlinked to each other in the OS. So the logical file system contains the metadata of the file and directory structure. If the application program doesn't have, in the sense application program in the sense the programs which are in the OS and related to the file management. That is another application program. That is OS program. It doesn't have the required permissions for that person to open that, to access that file, then automatically it will throw an error. So you cannot open. Logical file systems also verify the path of the file. Files are divided into various logical blocks. Files are to be stored in the hard disk and to be retrieved from the hard disk. As we have seen, this is our hard disk, and we have seen C drive, D drive, and E drive. So this is, whenever we save the file, that will be saved in the systematic way in the hard disk. That's what. And below this, we will find the directory for these files, which are files available in this directory. That is nothing but these. This is directory space for the directory for these files. What is the where the file is saved in the hard disk really, and regarding that file, we'll keep some content. So that is our directory. So files are divided into various logical blocks. Files are to be stored in the hard disk and to be retrieved from the hard disk, because once the file is saved in a proper way and maintain the indexing for those files, and whenever you want to open that file, systematically you can retrieve the data from the hard disk. That is what when you save, similarly you can retrieve the data from the hard disk. So hard disk is divided into various tracks and sectors. We have seen that CD, you will find some sectors and tracks also. Tracks means like this, that are tracks. So like this tracks. So it divided. This is sector 1, block 1, block 2, like this. The data is, the hard disk is divided into blocks. That's what meaning it is. So now the files are divided into various logical blocks. Files are to be stored in the hard disk and to be retrieved from the hard disk, and hard disk is divided into various tracks and sectors. Therefore, in order to store and retrieve the files, the logical blocks need to be mapped to the physical blocks. So for that one, we already seen the paging and how the logical address is mapped to the physical address. What are the MMU will do? MMU will convert your logical address into physical address, where actually your data is saved in the hard disk. That is the. So this mapping is done by file organization module. It is also responsible for free space management. The file organization module, this is some program. There are some programs ways. These programs will take care of file organization. So the first file organization module decided which physical block the application program reads. It passes the information to the basic file system. The basic file system is responsible for issuing the commands to IO control in order to fetch those blocks, because we want to save one file. So for that file, where is the place available in the hard disk, that file organization system will scan it. In the sense, the basic file system is responsible for issuing the commands to IO control in order to fetch those blocks, because we have to save the file in the free space blocks. So IO controls contain the codes by using which it can access hard disk. These codes are known as device drivers, because device drivers are the software which helps the OS to store to work for the device. So OS is the device drivers interface between the device, actually hardware, and your software for that device. So it controls also responsible for handling interrupts. It controls, because these are programs. IO controls are also responsible for handling interrupts. So file system implementation. File is a collection of related information. The file system resides on secondary storage and provides efficient and convenient access to the disk by allowing data to be stored, located, and retrieved. Because as we have seen, basically the file system is responsible for storing the data and maintaining where the physically data is saved, and maintaining the structure, directory, and under the directory where the actual file is saved. This is a file saved in the directory. This is a root directory. In this one, file is saved. So once the file is saved, that structure is available in the directory. That already we've seen first level and secondary level. So this is a route from here. The file is saved here. The required file is saved here. So this is the data structures part. So this is your the file systems resides on secondary storage and provides efficient and convenient access to the disk by allowing data to be stored, located, and retrieved. This is a basic fundamental job of the file system application programs which are in the OS. So following are the data structures to be used to implement file systems on disk structure, in memory structure. So file system implementation on disk structure. This store information about this total number of disk blocks, their location, free disk blocks, etc. on disk structure. Different disk structures are as follows: directory structure, volume control block, boost control block, feed file FCB. So what I want to say, so this is our hard disk. Everything will be in hard disk only. Once this is our C drive, D drive, E drive. So this directory structure will be available in the just below the C drive. Similarly for the D, we will find directory structure in some space in the hard disk itself. The OS will allot some space in the hard disk itself. For these files, we will maintain some directory here. This is like this. So volume control blocks, volume control, we will see one by one. This is the main thing. So directory structure stores the file names and associated inode numbers. As I explained, once file is saved in the C drive, regarding this file, we will maintain some index. That is not inode. Inode means index node. In this index node, we will find the complete information of this file. What is the file name? What is the way the file physically saved in this hard disk? That starting address, everything is stored in this inode block. This is this one. Volume control block. Volume control block stores information about the particular partition, examples, block pointers, free blocks, count, etc. So boost control block, because everything will be in the hard disk only. They maintain, OS will maintain where it is saving all these things, and it will do the partition, and it will provide some space for maintaining these blocks. Volume control block, boost control block. Boost control block is generally the first block of volume, and it stores the information needed to boot the operating system. It is also known as partition boot sector in NTFS, and boot block in Unix. Because whenever you switch on the systems, the OS will be transferred from the C drive to your RAM. That is nothing but boot control block. So automatically OS will come from, actually whenever you buy a system, the OS will be uploaded in the C drive by default. So the permanent storage. So whenever you switch on the system, the one of the Xerox, just copy of the OS will be transferred to RAM. That is nothing but boot block, boost control block. The first block of volume, and it restores the information needed to boot an operating system. It also known as partition boot sector in NTFS, and boot block in Unix. FAIR file FCB. So FAIR file FCB shows details about the files and has a unique identifier number to associate with the directory entry. So as we have seen, so whenever you want to save any file, some XYZ, so XYZ will be transferred into hexadecimal number for the each character. We find an ASCII code. This ASCII code will be, all the access code will be combined and we will get a unique number. That is the file number. That file number is saved in the directory. That is the file unique identifier number to associate with that directory entry. So this is your how the file name is converted into unique number. That number is saved in the directory structure. So file system implementation, the in-memory structure is maintained in the main memory and is helpful for file management for caching. Different in-memory structures are mount table, file process open file table, and directory structure cache, system wide open files table. So all these things will be stored in the memory only. The mount table stores information about the mounted value. The per process open file table. The open file table stores information opened by the process and it maps with the system open file. So everything OS will maintain record for everything for that particular file, for that particular process, what is going on, when it is open, when is going on, what is going on in the system, second to second, everything will be minute to minute will be stored in the these blocks only maintained. Directory structure cache stores information about the recently accessed directories. So if you open one file, so that one directory structure cache when at what time lastly opened, we are getting the information. So that will be stored in this cache directory structure cache. System wide open file table. So how many times the file is opened? So everything is entered in the FCB. So the system wide open file table stores the copy of the FCB of each file, open file. In it, how many times you open the file? In it, when it is created, that count, everything count will be updated in this open system wide open table. This everything will be in the hard disk only. That will be maintained. So we will see in the next class the allocation methods different, how the files are stored in the disk blocks. That we will see in the next class. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.